In this video, we're going to go over the circle theorem, and then we're going to look at some of the properties under the circle theorem. These properties, they are very important in the case where they have asked you to find some angles with regards to the circle. Now, without wasting much of your time, let's begin. Now, under the circle theorem, we have what we call the circumference. So the circumference, basically, this is just the distance around the circle. So whatever we're able to see making the circle, it is what we call the circumference. So all of this, it is the circumference of the circle. Now there's this line which divides the circle into two equal parts. So this line, it is what we call the diameter. So the diameter, this is just the line that divides the circle into two equal parts. So part A, this O area, and part B, which is this O area, they are equal. So this area, the size of that area and the size of that area, it is equal. Now in the case where they have asked you to come up with the circumference of the circle by using the formula, so the formula that you can use in order for you to come up with the circumference of the circle is given pi diameter. So when you multiply the pi, which is the constant pi, multiply with the diameter, you're going to get the circumference of the circle. And then we have what we call the radius. Now the radius, this is just the half of the diameter. So radius, it is the half of the diameter, or we can just say the line that runs from the center to the circumference. So that line, it is known as the radius. Now this radius, in the case where they haven't given you the diameter, in order for you to come up with the circumference, you can just say 2 pi radius, or we can just rearrange this to be like that, because we understand that the radius is just the half of what? Of the diameter. So you can use either this formula or that formula in order for you to come up with the circumference of the circle. Now there is what we call a chord. A chord, this is just a line that touch one part of the circumference to the other. As you can see, it is touching this circumference, this side, and also that side. It is also dividing the circle into two parts, but these parts, they are not equal. So in the case whereby we have this part, all of this is not equal to this, all of that, this part, yeah, that is what we call a chord. And then we have what we call the sector. The sector, this is just a fraction that is bounded by two radius. This radius that we are talking about this radius. This is the center, and also this radius. So it is bound by how many radius? Two radius. Radii, I mean. Yeah. So that is what we call the sector, and the part of the circumference. So it is made up and with the part of the circumference, like that. So this is what we call the sector there. And then you have to understand that there's also what we call the arc length. So the arc length, it is the distance from this part all the way going to that part. So the arc length, this is just the length of the portion of the circumference in a sector. As you can see, this, all of that, this, all of this, it is what we call the arc length. And then if you want to find the arc length is given by the formula pi over 360 multiplied by 2 pi radius, like that. Then that is your arc length. Now proceeding to the properties of the circle, we have this property which states that the opposite angles facing the center in a semicircle, they make a 90 degrees. So the angle opposite the center in the semicircle is 90 degrees. What are we talking about? We are just talking about this angle which is facing the center there, and also this angle which is facing the center. So angle D and angle B, they are making what? A 90, for the fact that they are opposite to the center. So angle B, it is opposite to the center, and also angle D, it is opposite to the center, for the fact that is line C and line CA or AC, it is what? It is the diameter. Why it is called how have I identified that this is the diameter? For the fact that it is dividing the circle into two equal parts. As you can see, this line AC or CA, it is dividing what? The circle into two equal parts, like that. Yeah. The other property is that all angles at the circumference are equal, provided that they come from the same chord. As you can see, we have this chord PR. So the angles that are coming from the same chord, which is, we have angle S there and angle what? Angle T, like that. These angles, they are coming from the same center, I mean from the same chord, therefore they are the same. So if we have 20 degrees there, also this, it is 20 degrees, like that. That's what we mean. So that is this property as well. It is very easy. You have to master it, and then it is very helpful. Yeah. And also the angle at the center is twice the angle at the circumference, provided that they come from the same chord as well. So for the fact that they are coming from the same chord, like this chord which is AB, the line AB, it is the chord. So this angle is bigger two times to the to this angle. So if I have a 20 there, which simply means that here I'm going to have a 40. That is what it means. So angle O, it is twice bigger as angle C, like that. Yeah. And also you have to understand that in a quadrilateral, opposite angles, they add up to 180. So as you can see, angle P and angle R, when you add them, they must give you 180. So opposite angles in a quadrilateral, they add up to 180. Also angle S and angle what? Angle Q, they add up to 180. When you add all angles in a quadrilateral, they must give you a 360. And also you have to understand that the radius, when it meets the tangent at the radius meets the tangent at 90 degrees. So since we know that the radius, it is the half of the diameter, so if you have a tangent, when that radius meets the tangent, it makes a 90 degrees. This is the 90 degrees that we are talking about here. So you have to understand also this property. It is very helpful. We also have this property which is very important as well. An exterior angle is equal to the to an interior opposite angle. So this exterior angle which is outside, it is equal to the interior angle which is opposite. Now how can you identify that I'm having this property in my equation? So the easiest way for you to understand that you're having this property in your equation, you have to have a tangent which is the line AC, this tangent here, and also when you have this angle here. So what you do is you go to your opposite, you mark like that, and then when you reach at that point, you go where there is the tangent. Which tangent am I talking about? The line AC. So you go to the tangent, and then the angle that you are going to find there, it is the same as this angle. So if I have a 20 here, which means that also here I'm going to have a 20. That is what it means. uh, the last property, it is that when two tangents meet, so tangent PQ and tangent RQ, when they meet, uh, the angle between them and the angle between the two radii add up to 180. What do they mean? They just mean that here angle O and angle Q, it is, they make 180, which simply means that if here there's a 90, which simply means that here it is also a 90, and then when you add 90 plus 90, they must give you 180. That is what it means. And then as you can see, since this is the radius from point O to R, therefore it is meeting the what? The tangent, hence it is making a 90. Same as OP, it is the radius, it meets the tangent, it is also making a 90. In the next video, we are just going to show you how to solve second theorem with regards to these properties that we have discussed. Make sure to go through them because they are very helpful.